Okay, so once you've talked about PCR, then you're gonna say, okay, we run the PCR, so we've got the perpetrator DNA, we've got the victim DNA, we've run PCR on their STR regions, we have all this DNA, but the funny thing is, when you put all the stuff in the tube and you run it through PCR, when it comes out the other end, it looks exactly the same. It still looks like a little tiny drop of snot in the bottom of the tube. And so how do we actually visualize the DNA? And this is a hard thing because DNA is microscopic, so how are we going to visualize it? So you're going to show them on the visualizing our sample, show them the picture, it's described above, A, B, and C, and just say, okay, think about it. How would you do this? How would this work? You might want to walk around and remind them that DNA has this phosphate on the backbone, and so it's negatively charged, if that helps them in any way. That the agarose gel is sort of a matrix, like a basket weave, if that helps them. So try to get them to the idea of gel electrophoresis. I'm going to explain it on the board here. And this is the way I normally explain it. And you're going to show them the gel. So you can bring out the gel at this point. Okay, so this is sort of 3D. Here's our gel, right? And it's got these wells in it that I've just taken a little snapshot of, okay? So it's got these wells. When we make it, we put the little cones in, and that causes this little dip. And this gel is like this matrix of sugars that's really hard to get through, okay? And so what you're going to do is you're going to set it down in a bucket of salt water. And that's basically what TBE is just salt water. So you've got salt water here. And then you're going to stick in electrodes. And we're going to stick in a negative pole here and a positive pole there, okay? And so what you're going to do is take the DNA, just doing orange, okay? And you're going to load the little DNA strands down in here, all right? And then you flip the switch, you turn it on. These negatively charged DNA are going to start migrating towards the positive pole. And as they do so, they're sort of snaking in and around and in between all that matrix. So the key is, the longer the sequence, the more repeats they have in their STR region, the slower it will go. So longer will end up over here, and shorter will end up here. So if they're a really short repeat, they're just going to zip through that matrix as fast as possible. So when it gets to the end, when you run it for 15 minutes, you will have separated them by size, with really long pieces sort of gathering right here, and medium-sized pieces sort of gathering there, and really short pieces gathering down there. So when you look at a gel, and we usually use some kind of fluorescent dye that intercalates into the DNA so that it glows under UV light. This time we're going to use food coloring just because it's simpler. But anyway, when you look at a gel, you'll end up seeing like bands like this, right? And these ones are longer, and these ones are shorter. And so how do we know exactly how long or short they are? Well, we can buy a prepackaged ladder that has all the sequences and has a little map that says this one's 1,000 letters long, and this one's 500 letters long, and this one's 250 letters long, etc. So you can tell, you can kind of compare it. We're not going to use a ladder this time because it's just really expensive, and so we don't have a ladder, but we're going to do the DNA. But we're going to compare them to each other, so really we're just looking for matching lengths of STRs. Okay, so at this point, I would pause and have the students load a gel. So I'm going to make a video of how to do that in just a moment. Okay, you ready?